Today's topic is going to be called neutralization. And as we already learned what an acid was and what a base was, neutralization is just putting the two together. If you take a look at the equation that I've listed here, on the page, neutralization, I took an acid, hydrochloric acid, I mixed it with potassium hydroxide, and I created a salt by doing a double replacement between the positive ion of the acid, which is the hydrogen ion, getting together with the negative ion. If we take a look, here's the positive ion, there's the negative ion, and in a sense we have created water. So there they are, the pieces of water. I'm looking at water instead of as H2O as HOH because when we think of the pH scale, water is right in the middle, and the reason it's in the middle of the pH scale is because it has an even number of H's and OH's put together. And when you write the formula like that, you can see what I'm talking about. So neutralization is the mixing of an acid and a base creating salt and water. And the net ionic equation that we have with this is simply, there's our H, there's our OH, and we're making HOH, pH of 7. We hear this term quite often and when people are working on their pool, getting their pool ready for the summer season. They have to shock the pool. The pool has a lot of chlorine in it. Chlorine is actually a base. Its formula is Na. Let me think about that for a second. Sodium hypochlorite. So it's NaClO is the formula, and it actually makes your pool basic. So you have to neutralize the pool by adding some muriatic acid to it. Muriatic acid actually is the street name for HCl. Anyhow, you hear this also with landscapers as they're talking about soil conditions under pine trees. It might be too acidic, and they would recommend using something to neutralize the soil so grass could grow. Just many different applications that we have out there. Now we're going to take a look, going all the way to the tippity top of this. How do you figure out how many moles of H are in a solution? So for the first question that we have here is, which solution do you expect would have the most H's? I'll give you a few seconds to think about it. We have two choices, 6 molar HCl or 6 molar H2SO4. Well, hopefully you answered the question and saying to yourself, all right, well, what's different about these two things? Is it the volume of the container? Is it the molarity of the container? Or is it have something to do with the formula? Hopefully you notice this right here. And because of this, you have two of these. This one has more H's floating around in it. Going to the next scenario that we have 60 milliliters of a 1 molar HCl and 30 milliliters of an HCl. That was supposed to also say 1 molar. I apologize. I'm going to put that in there. 1 molar HCl. Take a moment now and figure out which one has more H's floating around it. Hopefully you said this one. And hopefully the thing that you noticed that was different about these scenarios was not the molarity, not the formula, but the milliliters. And our last scenario that you take a look at, you got 60 of a 6 molar HCl and 60 milliliters of a 12 molar HCl. Hopefully you can figure out which one has more H's floating around, and that is going to be this one. So there are three things that actually affect how many H's or OH's are floating around in solution. If you take a look at our first scenario, we had the formula. So the formula played a role in this problem. In the second scenario, you had the volume was something of acid. And in the last one, it was the molarity itself. So there are three pieces, and these are the three scenarios that we need to know before we dive into an equation that deals with neutralization. And it's actually called titration. It's just neutralization with numbers. That's all it is. So anyhow, Moles depend on three conditions. We got the molarity, which is usually the number that comes in front of the M. We have the number of H's. Now you can put those two things together and you can call that molarity of the acid. Volume is usually, as you would expect, a V, and that's how they show that. So when you put this all together, MaVa, that would be what would give you the number of moles floating around in a solution of H. And then to figure out how many moles of OH you need to get that to a neutral point, it would be equal, but you'd only be focusing now on the molarity of the base, the number of OHs in the formula, and the volume of the base. So I only did half of the formula right here that we're going to be getting to in just a little while, but I just wanted to show you where this is all coming from. So when we talk about this situation of neutralization that we started off in, we've kind of come full circle. That if you have one of these reacting with one of these to make one of these, really this boils down into you have to use MaVa, which we just talked about before, which is the molarity, the formula, and the volume that all play a role in it. And if you notice that the number in front, that I have a 1 here, I have a 1 there, that means these things have to be equal. And because of that, this is the derived formula of a neutralization known as a titration. It's nothing more than a neutralization with numbers. So when you're using this formula, you have three pieces of information on the left side. The molarity of the acid comes from the M, like you'll see a number in front of an M. If you have a formula like H1Cl, well then you just multiply this and this together and you're all set. If you have a molarity and you have this scenario, you have to remember you have to multiply this and this to get your molarity of acid. Volume is whatever your milliliters or liters are. And that's really all you have to do is you're multiplying the variables in the equation, this titration equation, which is found on the back of our reference table. So that hopefully has given you a backdrop on how to use this type of formula. So here we go. We're going to have a scenario. We're going to have, say, we're going to titrate. We have 50 mils of a 2 molar H2SO4, and we're going to titrate that against a 10 molar NaOH. They may ask me how many mils or how much volume, how many mils NaOH needed to titrate. All right, plugging all my numbers in. I have this, I love this, I have this, and this. Wow, I have a bunch of pieces here. Well, we know that 2 times 2 hopefully is. Yep, you guessed it, 4. 4 milliliters, or 4 molar, I should say, for that one. So let's fix that. 4 molar. Now the nice thing about when you're using the complete equation, all you do is plug in the 50, and that takes care of that. On the flip side of this equation, I got 10 molar. So got to set this equal to 10 molar. And the reason is I only have 1 OH in there, so multiplying this times 1 gives me 10. And then all I need is X, and I have my milliliters. So now I'm going to multiply 4 50s. 4 $50 bills is $200. I'm going to divide that by 10, and I will have my answer for X. And if I go ahead and do that, oh boy, that 10 doesn't look too good. Let me fix that so that you can see that better. I wind up with an answer of 20. 20 mils is going to be necessary to titrate that. Now, if I wanted to if they just asked me how many moles of H are there in this solution, let me change that question just to show you a version of that. Let me erase this and show you how this differs from if they ask us in a scenario. Boy, this thing does not want to erase. say they ask me with this, how many moles of H plus exist in this scenario or in this solution. All I have to do is, I still have my 2 times 2 from these two numbers being multiplied, so I have a 4 molar solution, but remember that's 4 moles per liter. That's what molar is. And if you notice, if I try to use 50 milliliters, I'm going to have a crazy looking unit. But if I change that over to liters, I will notice that I will wind up with 0.05 liters. And in order to multiply that out, you'll notice that the units will factor out and give me the units that I'm looking for, moles. So if I have 4 nickels, I have 20 cents. In doing the mathematics. So sometimes they might just ask you, how many moles do you have floating around in the solution? When you have that scenario, that is where the only difference in what I'm doing with the acid information is I converted the milliliters to liters in order to get them to cancel out down below. Cancel, cancel, leaving me the units that I want for answering the question. Generally speaking, most of the time people will ask you for a titration where they'll give you acid and base information. That's where you have to plug in all the numbers. Hopefully that was helpful, guys, and have a great day.